So in this video I'm going to discuss the sliding subarray beauty. So this problem occurred in today's LEETCODE challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem states is like, if you know the sliding subarray concept, it is like you're given a subarray and then you have to slide it to the next subarray and then to the next subarray. So over here k is equals to 3. That means we have to consider all the subarrays of length 3. That is this, this and this. And you have to find out the second smallest number in every subarray. Okay, and if it is a if it is a positive number, then you have to make it 0, and if it is a negative number, you have to make it whatever it is. Okay, so for this first subarray, see what is the second smallest. -3 is the smallest and -1 is the second smallest. So we print -1. I mean we enter -1 in the returning array. For this -1, -3, -2, -3 is the smallest and -2 is the second smallest. So we return -2. For this -3, -2, 3, -3 is the smallest and the -2 is the second smallest. So we return -2. So I hope this is clear. Like the question is clear. So the basic approach that the naive approach would be running a loop of big O n squared into n log n. That is running a loop for every limit and sorting those arrays and checking like the xth that element. That is going to give you a big O n cube log n. You may optimize this, but whatever you may do, the code can never be of big O n, right? Like how much you can optimize this, the code will never be of big O n. But if you notice the question very minutely, it is stated that all the elements of the array are in the range of -50 to, let's say, nums of I. It is of the range -50 to 50. So we can do one thing. We can make a, like, if you know this concept of frequency array, so we can make a frequency array of size 101, because it will consider all the elements from -50 to 50. That is -50, -50, 50, -50 plus 1. That is 50 plus 50 plus 1. That is 101, right? So there are 101 numbers between -50 and 50. So you can make a frequency array like this and go on storing all the elements till k. Okay, and then if you know the concept of sliding windows, then you can like remove this element and then add this element. Like let me explain it to you with taking this example. Okay, so this example is -1, -2, -3, -4, -5. Now remember one thing, frequency of this has to be of the index of any number has to be greater than equal to 0, right? So if it is -50, we can add 50 to it and make it 0, and if it's 50, we can add 50 to it and make it 100. So I hope this is clear. So over here we can replace, like we can say that the frequency, what the frequency array looks like. Let's say this is -1 plus 50 is 49. So this is 49. So let's say this is 0, 1, 2, 3, ... Then 49, 50, 51, 52, 53, and again till 100, right? These are the elements of frequency array. So all are initially 0, right? All are initially 0. Let me emphasize on this numbers, because these are the numbers that you're going to need. So all are usually 0. Now the question is, once we get -1, then we make this 49, that is -1 plus 50, that is 49 as 1. Then you get -2, that is -2 plus 50, that is 48, right? I'm really sorry. Let's do it afresh. So it would be like frequency, it would be 0, 1, 2, ... -5 plus 50 is 45. So we will consider emphasizing on 45, 46, 47, 48, 49, and then 50 and ... Okay, so what the array looks like initially: 0, 0, ... 0, 0, 0, 0, 0, 0, 0, ... Okay, so now once we get -1, we are going to change the value of 49 as 1. Then we get -2, we have to change the value of 48 as 1. -3 plus 50, that is 47 as 1. Now see, we have, what was the condition? It was k is equals to 2, right? So we have done 3 elements, so we didn't need to do 3 elements, so we are not going to consider this. So after we are done with this, you have to run a loop from 0 to 100 and check what is the element which is at the position second. Okay, like for this, if I going to check from here, and then you see over here there is a 1, so there is 148. So we have to eliminate that because that is not lesser than equal to x, right? Because x was equal to 2. So we have to remove this and then check for 49. So over here, see, there is 1, 2. So this is the second smallest element. So what is the second smallest element? 49. But 49, as I have said, that 49 is not the second smallest. Since we have in the initial state we have added 50 to it, now we are going to subtract 50 from it. So what is 49 minus 50? It is minus 1. So we make it minus 1, right? Now once done with this, now as you know the sliding subarray, so when we are going to shift from this subarray to this subarray, then we have to remove this minus 1, right? So we have to make this 0 again and add this minus 3, that is this. Now what is the second? 1 is over here and this is over here, right? So what is the second? It is 48. What is 48? 48 minus 50, right? 48 minus 50 is minus 2. So what is it? Minus 2. Similarly, then we are going to check for the subarray minus 3, minus 4, minus 5, right? No, that is the last thing that we have to do. Sorry, I'm really sorry. It would be we have done with minus 1, minus 2, then minus 2, minus 3, then minus 3, minus 4, right? You have to make it for minus 3, minus 4. So for minus 3, minus 4, you have to remove this minus 2, and minus 2 removal means 48. It becomes 0. This becomes 1. This remains 1, and minus 4 we have to add. That is minus 4 plus 50. That is 46, right? So we have to replace this with 1. And now check what is the second smallest element over here. This 1 and then this 1, right? This is at the second position. So we make this. What was this initially? This is 47. So 47. So minus 50 plus 47, that is minus 3, right? So see, it is minus 3. Again we check for this minus 4 and then we do it. So that actually becomes minus 4, right? So let's try doing this, the same thing for this, for a better understanding. For this it is very simple because it is x equals to 1. So we have to just print the smallest element. So from this, minus 3 is the smallest. From this, 1 is the smallest. Since 1 is the smallest, as I told you that if it is a positive number, we have to replace it with 0. For this, minus 3 is the smallest. For this, minus 3 is the smallest. For this also, minus 3 is the smallest. So see, minus 3, 0, minus 3, minus 3, minus 3. So I hope this is clear, and this I have explained with the test, with my approach also, and this I'm going to explain with my approach. So let's say frequency. Let me show you what the frequency array looks like. 0, 1, 2. I am not going to consider them. We are going to consider from 47, 48, 49, 50, 51, 52, and dot, right? So that is 0, 0, 0, dot, dot. So 0, 0, 0, 0, 0, 0, 0, dot, dot. Okay. So once we get, so we have to first of all run the loop for the first 3 elements. So 1, minus 1, and minus 3. So for 1, what is 1? It is 50 plus 1, right? Remember I told you 50 plus 1. So 50 plus 1 is 51. So we have to replace this with 1. And I mean add it. Okay. So once we are done with this, so minus 1. So minus 1 plus 50 is 49. Add 1 to this. Minus 3 plus 50 is minus 47. So add 1 to this. Now you have to find out the second smallest. So we are going to run a loop from 0 to 100 and check what is the second smallest. So what is the smallest over here? 47. Then this is 49, right? So what is the second smallest? It is 49. But we don't print 49. What do we print? 49 minus 50. That is minus 1. So we print minus 1, right? Now we are going to delete this. According to the sliding subarray, we have to delete this 1, right? So what was 1 actually? 50 plus 1, that is 51. So we have to make this as minus minus. So this becomes 0. And we have to add minus 2 to this. So 50 minus 2 is 48. So we have to make this for 1. So what is the second smallest now? It is now 48 because this is 1, this is 1, right? This is the second smallest. So 48 means 48 minus 50, that is minus 2. So that is minus 2, right? Now we are going to insert 3 and delete minus 1, right? So if we delete minus 1, so 50 minus 1, that is 49. So we are going to minus, that is delete this and insert 3, right? So what is 3? 50 plus 3 is 53. So 53 is somewhere over here. So we have to replace this with 1. So what is the second smallest now? It is still 47, 48, right? See, it is still 1 plus 1, 2, right? So sorry, it is not rewritten. So okay, this is just checking. So this is 1 plus 1, 2. So now 48 is the answer, but 48, since I told you it's not 48, it's 48 minus 50, that is minus 2. So this is minus 2. So this is how this thing works. So remember one thing, if a frequency array consists of, like over here I am dealing with zeros and ones, but there may be a condition where this one can exceed. Okay, it can be 2 or 3. So in that case you have to check the addition of all the elements from the left to the right of all the elements of the frequency array, and once you have reached this thing, or in case you have exceeded also, so the condition is like let me do it. So condition is you have to run a loop from 0 to 100, and you have to make C, let's say a count. Okay, let's say there's a count which was 0, so you have to increase the value of count by frequency of I, and in case the count becomes greater than equal to X, then you can break, because that is the situation that you have to print. Okay, that is the I that you have to print, that is the element that you have to print. I mean not print, insert in the resultant array. So that's it. I hope this thing is a little bit complex, but if you can understand this was a very nice problem. So that's it. Thank you.